Right, right, right. Yeah.
I'm not sure. Why is it one? It's gone. But there's a thing on the wall to do that. Same thing happened here. Let me show you. Come here. There we go. Hit 3.
Look good?
Why did you make this? Four might be a little much. Gotcha. No, that's not bad. Oh, that's not bad.
He's the only one messing with this. Who else is
No,
messing
one's
with
okay. 5 is bad. Is that okay, guys? Yeah. Cool. Mood lighting. Alright, are we getting signal?
I just did it and then somebody changed it. I was like,
Right.
what's happening?
What's going on here? You said you push the button, and it would change once, and then it changed again?
Yeah, I was like, oh, that makes sense. But, okay. Same time. Alright, I gotta go track. Alright, I think this one's good. Yeah.
Good morning. How's everybody feeling? This guy's feeling good. Right. Yeah. Welcome to DerbyCon Sunday morning. Glad you can make it after the sweet party last night with the offspring. So talk is Red Mirror, bringing telemetry to red teaming. A little bit about myself. I'm Zach Grace, lead the red team, pen testing and vulnerability management at Fortune 100. I am on the Wisconsin CCDC red team, and that'll be important in a minute. I am an elk noob. I do not claim to be an expert in a bunch of this stuff. I just found a bunch of this really useful, and I think you probably will too. If you do the Twitter thing, that's my handle. So this actually has a little bit of an origin story. So like I mentioned, CCDC. So if you're not familiar with it, it's a collegiate cyber defense challenge. Basically teams of college students get together and they're giving different environments to defend, or they have to build environments themselves against basically a professional red team, right? So it's sort of like the pros versus the Joes, and of course the red team always wins. In our setup, one of the challenges that we always have is it's a virtualized environment, so the teams are always able just to click the reset button and just now they've reverted it back to the original state, right? Which means also they have kicked us out, and we have to go back and re-compromise those systems. And if we're not paying attention, they can do that and then change the passwords and then harden the systems, and then we kind of lose our access, right? And then we have to work a little bit hard to get it back. So I decided for last year's competition that I wanted to build like some sort of like board similar to what the blue team has as far as their service uptime. So one of the goals that the blue team has is to keep their services up and running. That's a component of their scores. So that they're supposed to be like a pseudo business, right? And as the services go down, they don't accrue points, but if the service is up, they do get those points. And so for us, I wanted to make something similar so that we know that, hey, we actually have these systems compromised, or no, we don't have these compromised, or hey, they reverted, or we just lost access. We should probably go and hit that box again and get that access back. So I built this thing. It's called Pwn Board. It's sort of a very kludgy thing. It's sort of unsupported at this point, and I'll show you why in a minute. But basically, it was every time we would compromise something with like Empire, I was grabbing, those connections, pushing that to a Slack channel, grabbing the message out of a Slack channel, and then populating the board so that we knew that, hey, we were constantly getting those check-ins, or we had new systems pop online to monitor this. And I ended up throwing it up on Twitter and like immediately got a response from Virus, and he's like, dude, I need your code like now, because so if you don't know Virus, he's out west, and he was working on the Western Regional CCDC, and also helps with nationals too. And he's like, that's going to fit really well into all my stuff. So I sent the code over to him, and then I started asking questions about his stuff, and he's like, oh yeah, and I use an elk stack for all of theirs, and we use these things called beats, and like I knew nothing about this, right? I'm like, well, what's that? And started, asking lots of questions, and realized like how awesome of like an ecosystem like all the beats libraries really are. And so that got me thinking about telemetry and like how could I do the poem board thing better, and then ultimately made it into something a little bit bigger. But the beats that he was mentioning are they're called beats now, used to be called libbeat, is basically a Go library that you can use to build basically little monitoring tools, right? So they're meant to take some sort of data, some sort of metric, and then ship it off to like an elk stack. And they're really small, and there's no dependencies, thanks Go. And it's pretty sweet because we're going to focus on like some of the primary ones that are out there, but there's also about 70 community beats. So if you can imagine like a log source, there's probably a beat out there for it, or it's fairly trivial to write your own. So why telemetry? So really, my opinion is like the red team should be making the blue team better, right? If we're not actually improving things, like we're not really doing our job. So as we were building out the red team at my organization, I thought about, okay, well, what would I need in the end when we're all done with, say, like a multi-month long engagement to actually have the data that we need to do effective like knowledge transfer and help them get better, show them exactly where and when like things happen, so we could improve detections for the organization. And then I sort of made the correlation back to like that poem board of, hey, like maybe we can do all the get all the data from all the streams and actually put that together in some sort of fashion. So this talk is not really about like just here, plug and play. This is more a choose your own adventure type of talk, because I've never met two red teams that have the same infrastructure. So I'm going to talk at a higher level of like, here's some different things that I found that were really useful, and some might be useful to you but weren't useful to me, and that's okay. And then I'm going to release some code here after the talk, and you can use it if you like it. If not, that's cool too. So I just want to give a shout out to some prior art. So if you like Splunk versus Elk, there's a cool project that Vincent Yu put out called Cobalt Splunk. It basically sucks up the beacon logs and web logs and then puts that into like a Splunk app. And as of about 4 hours ago, looks like there's another Red Team Elk project out there. I literally woke up this morning. I'm like, hey, I have a tweet. Somebody tweeted it at me, and it was these guys who just presented it at BrewCon, and now their talk's up too. So they have a little bit different approach. I think it's really cool, and I like some of the stuff that they do better than a few aspects of mine. But there's some stuff that mine does that theirs doesn't do, and I'll kind of mention that. So for red teams, we think of like typical session logging, right? I kind of talk about a few different aspects of that here, right? So if you're in a console, like a shell, right, or like Bash or ZSH, you probably use script to log all that out. That works fine, but it's hard to grep through. It gets big and messy. You've got, for MSF console, you can spool all that out as well. For Empire, the stuff gets written to agents.log, and for Cobalt Strike, it gets written to the beacon logs. And so this is a lot of different information that gets stored in like different places, and it's hard. You go to write reports, like I can't remember what I did last week, let alone like 2 months ago when you have long-term operations. So that makes this kind of hard. For the network side of logging, this is typically what I've always seen, right? We're just going to like PCAP all the things, like PCAPs or didn't happen. So what could go wrong with like these current approaches that you could basically forget to start them, or something can happen and not realize it, right? So maybe you fill up a disk or something crashes, or you delete that VM that you were working on, and now all those logs are gone. Like there's a number of things that could kind of go wrong. So looking at something more like a centralized logging solution, I think kind of makes sense for us going forward. So like I said, there's nothing centralized about that. It's all on different servers. If you're, red team, you're using multiple team servers for like Cobalt Strike or multiple Empire instances, right, spread across your infrastructure. Now you have to go to each one of those to find all the details on that, and that's a bit of a pain. It makes it kind of difficult to construct those timelines of what happened when. If I'm working with the blue team, I want to be able to tell them that, like, at 9 a.m. on Sunday, all right, we did this thing to this system, and here's what we saw. That way you can actually help them go back and correlate in their logs, or flow data or whatever makes sense for that sort of detection. Makes it sane, right? Like trying to grep across tons and tons of logs across multiple hosts gets to be a bit of a pain and not very efficient. And then what we found is that once we started collecting some of this data, it was interesting to us in that we could find different things that we make assumptions a lot in pen testing and security in general, right? And we found once we actually got some data, we can make better insights into recommendations that we're making, and I'll show a couple examples of that. So kind of looking at what data could we possibly collect. This is obviously like a super simplified diagram, and you'll see the insane monster that is our infrastructure in a couple slides. But you basically have the implant. You've got the raw C2 traffic that goes back and forth between you and like your C2 servers, and then you've got that communication of like standalone tools, and maybe that's going through your C2, or maybe that's directly against hosts, right? So you can do some of these same principles for internal engagements as well. So like I mentioned, this is all based on like an elk stack. So this is the general flow if you're not familiar with it. The beats are the things that we're going to use to collect data. We've got Logstash will process and aggregate data. It's a pretty, it's sort of like awk on steroids. It can modify and manipulate data as it comes in. It can also enrich it. Elasticsearch is essentially the data store and querying engine for everything, and then Kibana is like the UI on top of it. And so we'll see a couple of those components now. And so for collecting that data, like this is what I found to be the most useful for telemetry. So packet beat, file beat, con beat, and metric beat. So packet beat's pretty sweet. It decodes and stores common protocols. So HTTP, DNS, MySQL. There's a bunch of fairly common protocols. It can also capture flows. So like flow diagrams. That could be useful too if you don't want to capture like full data. We found this to be really, really useful for like actually monitoring like the C2 infrastructure. So think about having like redirectors out on like your, the edge, like you spin up an EC2 instance or something in DigitalOcean. The thing that's out on the edge actually receiving that initial traffic. This is great for that because it literally will just capture that sort of data and then send it back to you, even if you have other structure back behind it. The only limitation that we found so far with this is that only supported protocols you can log, right? So if they don't have a protocol, or if it's on a funky port or something like that, you're not going to capture it. So with C2, it's pretty well defined, right? Like I know I'm always going to have HTTP on port 80. I'm always going to have DNS for DNS beacons, and so that makes it pretty good for that use case. So here's an example packet beat config. This is the one that we use. It's pretty simple, which is why this is nice. Like we're not having to reinvent the wheel to gather all this rich data. You basically tell it what interface to listen on. In this case, we're not looking for flows. You can enable it. Literally set it to true and restart the service, and now it's capturing flow data. And you can define which protocols. And so for us, when we're capturing Cobalt Strike hybrid data, right? This will capture all of that. So it gets all of the DNS traffic, where it's actually full DNS queries, as well as the responses that go back for them, as well as we're capturing like the full, I keep showing up there. Go away, little guy. We're actually capturing the full requests and responses for the HTTP traffic as well. So then we can see what we're sending back and forth on those different requests. One thing to note, if you do try to implement this for like Cobalt Strike, with the malleable C2, you're able to define all sorts of different MIME types for it. You have to have the MIME type match here. if it's not in this list, it's not going to capture it, right? So I think one of the profiles we have been using, like using audio/MP4 as like its profile, and it wasn't capturing it, and I couldn't figure it out for a while, and realized that, oh, well, it's because that MIME type wasn't in this whitelist here. So just keep that in mind if you're going to use that for a couple on strike. So ConBeat is similar to PacketBeat, except for it can monitor all TCP connections. So instead of being like a whitelist of protocols, it's any TCP connection that happens. I think the other interesting part about it is it actually can capture the command line. So on the left here is an example of what ConBeat can actually capture. I think I was just doing, like a IMAP scan, TCP INMAP scan, right? Because the key here is that only full TCP connections are logged, right? So if you're trying to do like a SYN scan with INMAP, you're not going to catch it. But if you're doing just sort of like normal operations, say with like Metasploit or something like that this might be great, or might be fine. And as far as I could tell, there was no UDP for this, right? So if you're doing anything over UDP, it's not going to get captured. So again, depending on your use case, this could be like a good option. Another one is MetricBeat. So this is newer. It looks like they're trying to replace ConBeat with this one. So this one is an official beat from Elastic, whereas ConBeat is one of the community beats. So this one is very similar, that it only logs full TCP connections, but you get other interesting things like there's like network I/O information you get from it, so like number of packets and things like that. So there might be good sort of like general data. So, how much data are you sending to these guys? If you're scanning the heck out of them, right? Like, oh, it's 500K worth of traffic like at a constant rate. Like, it might be interesting to know. I think this is probably one of the more useful ones for, I guess, gritty detail purposes. Obviously, you've got PCAPs, right? Everybody's used to running TCP dump and dumping that out to a file. So this is a flow here put up by Elastic talking about how you can actually get data from Wireshark, or obviously TCP dumper, basically any sort of PCAP format, and then get that over into an ELK stack. So to do that, and kind of walk through that a little bit. So you basically can run and capture packets. So here's an example of running T-Shark directly to generate that. So one of the cool features of T-Shark is, I'm not sure when they publish it, but there's this EK format, so it's basically Elasticsearch format, which means that what it's going to output to standard out is a single line JSON format for each packet that can just be directly ingested by Elasticsearch. Whereas I think their normal JSON is like one giant JSON object. So it helps with the format options. So in this example here, I'm showing you could put this within something like Supervisor D, so that would automatically start up, as soon as you booted the system up, and we'll start logging those packets, and then you don't have to worry about that not running. My only caution about this is I found it's extremely memory intensive. I think for whatever reason, it seems to keep all that data in RAM, like as it's writing out the JSON files. And when I first ran this, I'm like, why did this thing get killed? Like, I got killed on T-Shark, and so I started looking at it, and I'm like, oh, well, this just ate up like an entire gig of RAM trying to capture like a single IMAP scan of a host for like 65,000 ports. So it is slick that you can do that, but it seems like it's very inefficient. So I think probably what a better workflow is to actually use TCP dump to T-Shark, which then converts to JSON. So here's a couple options for doing that, right? You can use TCP dump and record, kind of like you classically have, and do some rotation here. There's a couple keys is that you should make sure that you're not also recording your Elasticsearch traffic back to your hosts. I couldn't figure out why I was generating like tons and tons of traffic for a while. I'm like, why is this like gigs of PCAPs when I'm trying to scan like a particular host? And then I realized, oh yeah, well I'm also capturing like the traffic sending back to ELK, which then generates another log. It's like this recursive loop and just like balloon everything. So don't screw that up like I did. So you can basically dump that straight to a file like you typically have in the past, or you can use T-Shark to do something similar and do some rotation on it, and then basically use like a for loop and the T-Shark command, similar to what we saw in the previous slide, where you were basically reading that PCAP file instead of reading it from the wire as it's happening. Read it from that file, run it through the parser, so it kicks out that Elasticsearch, and then dumps it to a JSON file. Or I haven't played and gotten this to work, but TCP dump does have a -z option for post rotate command. So say you want to rotate every 10 megs or whatever you want it to be, you can specify a command to run after that. So you can maybe use like that T-Shark to JSON command, so that once you rotate, it'll automatically convert to JSON, and then if you set up a file beat listener, you'd be able to automatically convert that and then import that into like an Elasticsearch stack. So here's an example of file beat setup. So file beat is another one of the beats that's available for Elasticsearch. It focuses obviously on files, creatively named, and it's pretty slick, and we're going to use probably file beat for like the rest of the demonstration here. It's slick in that you can basically just point it at like here's a log location, and it will automatically ingest those logs as they come through. It's slick in that like in packet beat the same way, and really anything that uses libbeat is it will know that if it starts to lose communication to the ELK server, you're not going to drop those logs, right? So if you have a syslog, sometimes it just goes to like dev null, whereas in this case they're guaranteed to get there as long as eventually it comes back up, or you don't lose disk or services don't crash. It's like I've screwed up infrastructure like our Elasticsearch server where it went down, or we ran out of RAM on our box because like this stuff is all like super memory intensive, and so it went down, and well the packet beat and the file beat listeners were continuing to spool that up, and then as soon as that came back up, it flushed it all out and was able to recover all that data, which is great. So file beat is able to read in individual log files, and it will monitor them for changes, and so when it sees changes, it will reparse them and then ship them off. So in this case, we're looking at an example here where I've got a varlog pcaps. So imagine I'm writing that data out with via T-Shark to a JSON file, and now you've got a couple of key things I've got highlighted here, right, is make sure this points to like where the log files are, obviously. This JSON keys under root basically means this is a structured log file format, which means that it's one line per entry, and each line is a JSON file in itself, or JSON object structure. Excuse me. And obviously down here, change your Elasticsearch output to where it needs to go to. So this will ingest and then take any files that it sees and shove this PCAP data over to an Elasticsearch stack. So big advantage of this is like you can do all traffic, right? You can use filters to ignore traffic. Obviously, like being able to like filter out your own Elasticsearch traffic is pretty handy, so you don't get a whole bunch of garbage in there. The only limitation as compared to like conbeat is that you can't tie that traffic back to an actual command that you ran. Now, if you can start overlaying other, say logs, like you're doing like a session log on like your bash console or something like that, and you're overlaying that with this type of traffic, you can get something similar. All right, so now we're going to talk about Cobalt Strike, right? So that was sort of primer on like what are these sorts of things and how can we kind of use these. Now we're going to talk about how we actually use this with Cobalt Strike. So this is a representation of what we use for our infrastructure. So I blogged about this before. Link it down at the bottom. So we actually use on-prem team servers so that we can ensure data protection and things like that. We use redirectors out in AWS so we can spin up however many instances that we want. We're actually running multiple versions of Cobalt Strike. So we have what we call our working, which is like sort of our day-to-day stuff. Like I'm going to run commands, do attacker type things. And we've got our long haul, which are supposed to be like super low and slow. As well as we also have a dev as well, but I need to put 3 of these up here. So obviously, like, we've got a good amount of infrastructure, right? And like, how do we like start to get all this stuff and correlate this and understand, what the hell is going on here? And so in this case, in the diagram, we kind of see here where we've got packet beat. So packet beat sits on these redirectors. They're the ones that are going to accept that C2 traffic for us. Packet beat is going to capture that data, forward it back to our ELK stack. So we're going to get all the visibility here of whatever is coming into the box, we know about it. And on the backside here, we've got file beat with a custom JSON logger that I wrote that we'll do a demo of here in a minute. But it's basically logging everything that happens within like the Cobalt Strike infrastructure that you're doing, right? So if you're running commands, I know that the operator ran that command, right? Or if when beacons show up, that also gets logged as well. So we'll see some examples of that. So with Cobalt Strike, they break the logs down by day and by host and by type. So here's a little screenshot of that. It can be done to read these logs directly. They're not very clean. They're multi-line logs with a funky timestamp on them. And so you're able to, you can parse them with Logstash if you wanted to do that. But what I found was that it was missing some of the data that I was kind of interested in. So there was what's called artifact data, right? So if you go and you try to generate, there's a couple of report types. One of them says, show indicators of compromise. And then you're like, here's a whole bunch of cool data that comes out of it. Like, here's file hashes, but it just says like, oh, you dropped these 5 file hashes on your engagement, but no correlation to like what hosts or what times or when or where. The data is in there. It just doesn't get pulled out by default in that default report. And it also doesn't get written out to logs. And so when we started looking at this, one of the things I was seeing was that, well, where is this data, right? Like I'm seeing that when you generate those reports, it shows that here's your like MITRE ATT&CK TTPs, which is one of the ways that we're using to communicate to the blue team. So I'm like, well, I want that data, and I want that data in ELK, and figured out that it's not actually in the log, so I had to go hunting for it and write code, which doesn't always turn out well, but we'll get to that in a minute. So basically decided to write a Cobalt Strike structured logging logger. So basically, like I said before, structured logging is where you've got a JSON log, one line is an entire log entry, and it has all of the correct key value pairs that you need for your log entry. It works really well with file beat that you can just ingest that. You can also do like data enrichment, things like that with Logstash as stuff comes through. So it works really well for like that entire flow. All right, so now we're gonna try this. What could possibly go wrong? All right, so let me find the right window. Hey, we're disconnected. Like I said, what could go wrong? All right. So this is Cobalt Strike if you haven't seen it. There's a couple of things that I'm going to show you here. So there are a few things. So under the hood, there's this thing called aggressor script. So Cobalt Strike has basically an event-driven library that kind of feeds and updates all the data in the UI. So like, oh my guy's dead here. This is awesome. And so let's see if we can start him back up. Oh, there, we'll just have to recreate this here. I see why. Oh, good. Evidently it updated itself. That's fun. All right. So while that's trying to come back up. So aggressor is the programming language you can use to interact programmatically with Cobalt Strike. It's event driven, and I'll show you this while that's loading. So you can write scripts in it. It's kind of like It's a weird language, to be honest. And what I loaded is something called Event Spy. So it's out there in the, oh yeah, that's gonna be super hard to see. Sorry, changing stuff on the fly here. So it's in the documentation. It's like literally one of the first things. So anyway, it's like JavaScript where there's all these events, right? So it's like on something, right? So in JavaScript, you've got like on click and events like that, where in Cobalt Strike, you basically have like, on beacon check-in or different events like that. And so what I'm going to show here is this little event spy script that I just loaded. And we load it through the script manager, and now I go to script console, and we can see that a bunch of stuff is just constantly getting like puked out here, right? So some of these obviously aren't very interesting. Like there's this heartbeats events and things like that, so that you can write timers for things if you want something to happen like every second and every couple seconds. Those are there. Let's see here. Let's see if our VM's ready for us. Hey, you're live now. Let's go back and copy. Sites, copy. There we go. All right, cross fingers. That looks good. Yay, we got shell. Let me do this. All right. So that's a good thing to actually kind of look at. So now we've got, hold on. Let's unload this bad boy. So obviously there's a lot of data that gets just dumped out here, and it's hard to kind of like read and parse through. We'll see that like somewhere in here. Then we get a new beacon. But basically every event that happens gets logged to the subsystem. And so the tool I ended up writing here, let's go to this shell, one that you can actually read. This is a JSON logger. Oh, it's better on your screen than mine. And so this is just like this monster CNA file. Part of it is because I purposely put in all the MITRE ATT&CK TTP stuff in here. There's a note basically says this should probably be a Logstash plugin, but I haven't had time to do that yet. But basically the reason for doing this is that Cobalt Strike is really cool about anytime you run an action, say you spawn in a new shell, right? There's some TTPs that happen from that that will generate the correct MITRE ATT&CK tactic for it, but it doesn't actually like tie in the phase. So it's missing some data that I wanted for like some visualization stuff that I'm going to show you. So I ended up adding this stuff in manually. Eventually there's probably a plugin, or I should really hit up Rafi and tell him that I would like this data in there, and he probably would have it done in like the next release. But basically it's configurable here on top, so you can configure what you want to log or not log. Some of these are really noisy, and I just don't care about them, so I just disabled them, but I did write the code that like if somebody wanted to ingest the stuff, you could. So let's go down here, past all the MITRE stuff. And so basically it's a whole bunch, it's a giant if statement, because there's no case or anything like that in here, that says if it's this event type, remember like this is all event driven, so like on beacon input, which is you as an operator type something into the console, like this event is going to fire. Since I'm listening on every event, I'm going to capture this event, parse this, and then shove this into the log. And so I wrote a custom JSON encode function, which probably will break at some point when somebody has some crazy, character encoding or something like that. For the most part, this seems to work pretty well. All right, so that's the file. Let's see here. So let's start this up. So I like using like the console line aggressor script to run this versus being in your own. That way you know it's going to constantly run while you're connected to or not connected to the team server. Let's see here. All right, cool. So if we go back to this guy. So we should see that, hey, our log bot has joined us, right? So now we know that we're constantly connected to it and monitoring those events. And we're probably not going to see too much right now because we're not doing anything with it. But if we do, say like shell, who am I? Now we get some output, right? So let's go back and see what happened here. So I'm just going to kill this guy. So you see that we have a JSON file, and now here's what we just ran, right? So we can see here that we've got what I tested, beacon to run who am I, the host called home, here's the results, all that, which is great. It's all in JSON now, so it's structured, and we can actually import that data. All right, we'll fire that guy back up. Oh, one other thing I was going to show you. All right, so since we got it written out to the file now, we're going to use FileBeat to ingest those into Logstash. The key here is a couple of things. If you're doing something out of the box with FileBeat, it works pretty well. So say like you want to import Apache logs or Nginx logs or something like that, you don't have to do anything. It's really sweet. However, if you want to start doing custom stuff, it gets a little ugly. Not too bad. There's some decent tutorials out there, but what I found is the biggest pain, and partly because I didn't know what data was going to get shipped out of Cobalt Strike, or all the field names when I started this, was developing this fields YAML. And so this is basically a file that describes all the data that I want to shove into the Elk stack and what data type it is. The reason why the data type is important is in Elasticsearch, especially for strings, there's two primary data types. Like one is just text, and then the other is like a keyword. And so when you start doing visualizations and things like that, you can only do aggregation on keywords. And that gets important when you actually want to like do cool things and pretty things with the data. And I found it out the hard ways. I don't know how many, like probably in the first couple of weeks when I was building this, just had to completely change this constantly because I'm like, crap, I didn't know that was a thing I wanted to do. And one of the bad things, unlike like a SQL database where you can run an alter command to change a table or a column type, you actually have to create a new index and migrate the data over, so you can't really update it and you have to re-index it. So it's a bit of a pain, but once it's up and running, it's pretty awesome. So, these files are pretty simple. It basically just describes all the fields that we could possibly log, or that I'm logging out of here so far. The main configuration file is filebeat.yaml, so it's pretty simple and straightforward. There's these things called prospectors. I think they now change it to inputs, similar to Splunk. And we're defining like where we're going to find our files at. And we've got basically, like we saw before, we're saying that, hey, there's JSON. This is JSON, right? So we want to import it as JSON. And then down here we just have a couple different things. We point to our fields YAML, so it knows that these are the custom fields that we've got. Here's the template, and this is probably like the most painful part about all this that I've run into is like even if you define the fields, you still have to give a custom template to say here's the mapping of what I want, and I'll show you what the template looks like. Oh, that's horrible to read. I'm sorry. And so basically it looks a lot like the FileBeat or the fields YAML, where it basically just defines these, but it's in, I guess, a slightly different format that's needed for Elasticsearch. I'm not, like I said, a bit of an elk noob, so I'm not sure that the clear differences between why you've got fields YAML and also this template, but if you don't have the template, it's not going to work very well when you go to actually put this new beat into Elasticsearch. So we've got basically everything is already there, all the data is there, and so now I'm going to run this interactively. This will run as a service, but just so we can kind of see the data as it's getting ingested here. Do this, and let's do -c filebeat.yaml. So this is probably going to scroll super quick, and it's done. All right, so what we're seeing here is that FileBeat went to those files, parse them, and this is what it's sending over, right? So you can see this is obviously very similar to what we just had in terms of like JSON logging. So now the fun thing is, if we're lucky, let's reload here. Let's go to Discover. All right, and I have this named as team server index, and there you go. Here's your data. So here's the commands that I've been running. So I think one of the fun things about Elasticsearch is I can set this to say, constantly query and show me updates here. So if we go back to like our team server here and tell it to give me the IP config, here in a second we should see that the data then gets imported. Maybe. Are we still running file lead? Oh. Yeah, we are. Okay. So there we go. So now it shows up. So imagine this now, like starting to put this into like each part of your infrastructure, start to scale this, and this data starts to kind of come together, right, in a pretty sweet way. Go back to the slides. So yellow. All right. So we'll get back to like what does all the really cool stuff look like in a minute. I just want to touch on Empire here quick. I know a lot of folks use Empire. You can use PacketBeat for like your edge infrastructure the same way that I'm using it for Cobalt Strike. They do have unstructured logs in your Empire folder, downloads, whatever the agent name is, and then agent.log. It is possible to parse those. This is what that log kind of looks like. So you have a funky date format. You've got and whatever the output was from that. So you can run modules. So you see that you task the agent to run this particular module. It just kind of gets dumped out in this giant log format. You can parse it with Logstash. Works pretty well. So the easiest way that I found is you can find a grok pattern. So in Logstash, you can find these things called groks. They're basically like regular expressions, named regular expressions. And so in this case, I made a regular expression or a grok that matches the format of the date that Empire has, and then added this line here to use this to parse it, right? So you've got, if the pattern at the beginning starts with like the Empire timestamp, then grab everything else that comes after that and chunk that up. So that kind of looks like this, right? So where we're matching this date out, we get this data gets matched, and so then that would get parsed and put into it. So this is sort of the reason I also wanted to go down the route of writing like a JSON logger, because this is cool, but it's a little tough to pull this data out. It's not quite as useful. I looked a little bit into like doing the work to do this, and it looks like it's definitely possible. There's already some logging infrastructure within Empire, but you'd have to go in and enable sort of a JSON format and have a little more detail around what each of those is, because it's just sort of like, and dump stuff to the log, right? You might want to go like, hey, we ran a module, or here's an output from something, so giving it more context, whereas right now there's not a lot of context to it. For Empire, there's a pretty cool project that I saw come up a few weeks back. It's called Attack Empire, and it's written by Daniel Stepanek, and it's pretty sweet that it basically just maps out Empire module execution to tactic IDs. So if I were going to do this for an Empire infrastructure, I would basically build basically a Logstash plugin to take this as you saw that come across the logs, and you would identify those modules, use like Daniel's code here to grab that and then basically say, oh, well, because you ran the screenshot module, it's tactic whatever. And so that would be a quick way to kind of get that additional rich data into those logs. I'm just going to touch on Metasploit for a minute. So I kind of mentioned a little bit before, right? So most things you're going to do with Metasploit are TCP based, so those packet beats and con beats will work pretty well. It's dumping out to the spool log typically, so you can capture that and parse it similar to how I mentioned with Empire. And for custom structured logging, like it's definitely possible. Metasploit also has a bunch of events under the hood, so there's definitely like on session and things like that where you could write your own overloaded methods then to just take that log data and then write that to a structured file as well. And then you'd have very similar data to like what I've got in Cobalt Strike. I guess I'd be remiss if I didn't mention like web hacking. There's already a pretty cool project, and I've used this a bit in the past, that will take Burp Suite output. It's a Burp Suite plugin written by Thomas Patsky. Hope I'm pronouncing that right. That will take all that data and then shove that into Elasticsearch as well. So I found it fairly interesting when I was just using it for like app testing. Like if you're running like fuzzers or sometimes you're using like the active scanner, you never really see like what happens or what, other than like, oh, this has a finding or no, this doesn't have a finding. I was finding instances where I would get like 500 error messages where it was enough to like sort of show that there was an issue there, but never really surfaced through like the active scanners. I was able to go and see that, hey, like these requests made 500 HTTP error messages, and then sort of like tease that out and then find vulnerabilities based on that. So, sort of outside red teaming, that's a good use case. Or if you're trying to proxy commands or your web traffic, this is another good way of getting that data in there, besides like the packet beat libraries and things like that, especially for SSL. All right, so what were the outcomes of doing all this stuff? I think first and foremost, like we've used this to debug our infrastructure. Like we'll break things occasionally. Like it's fairly complex on how we have things stood up, and we'll see that, hey, well the beacons are making it to the redirectors to the edge, but we screw something else up after that, right? So it's helped us in debugging and troubleshooting. And operational security. I think this is probably one of the more entertaining things. Literally the first day we installed this, we kept having this issue of, we call them like zombie or phantom beacons, where we would just get like, the little black icon shows up. It's like, hey, somebody's trying to check in. So if you have a DNS beacon, you have to tell it to check in, and then you'll get, that rich look like this, where you've got the IP and all the stuff like that. Otherwise, it's just like a black computer icon right here, and you don't see anything until it actually checks in. So we kept thinking like, well, what's trying to check in? It's really strange. And we started doing some analysis on it, right? Because we actually have the data now. And being an internal red team, we tend to write some stuff and blow it up internally to test things out. Like, hey, we want to see how well our macro detection is working, or something like that, right? So we'll write our own payloads to get dropped and exploited in the environment on like our test or dev infrastructure. And clearly, like, the top 3 rows here are legit. Like, these are our egress IPs. And then all the other stuff are security vendors. So we've got, in the screenshot, Bitdefender. Bitdefender is like super noisy. They were the ones that were constantly like creating these phantom beacons and really sort of annoying us. And then we've also got OpenDNS hits us quite a bit, and Palo Alto. And it's sort of annoying just to get that stuff popping up all the time, because you're like super excited, like I got shell, and then it's like, no, I didn't really get shell. Like these guys are just monitoring my crap. And so now, since we know and we're actually watching this stuff, we can do something about it. So so we started implementing some stuff, and so shout out to Jason Lang in the back, Curious Jack. Hey, Jason. He gave a cool talk last year at DerbyCon about some of his red team tips and tricks that he had. And if you check out this one here, it's basically a .htaccess file that he wrote that will that he's identified like a ton of different security vendor subnets, right? So like here's their entire CIDR blocks, right? And he redirects them to different places, right? So redirect security vendor A, security vendor B, and be on your merry little way. And so we did something very similar. We used Nginx, so I converted that all over to Nginx format and put that into place. And then so here's us actively subverting some of those security vendors. So it's kind of nice to be able to see that, and we go, all right, we know now that like at least this part of the attack is somebody's at least aware of it. We maybe need to change our tactics. We need to burn that infrastructure down or change what we're doing. It's also been pretty interesting just to see like visually, can you find the data exfil in this? It becomes very clear very quickly like how predictable like some of our tooling really kind of looks like. It's very clear beaconing, right? You see the very periodic calls coming in, and then we also see like the DNS exfil, where all of a sudden like you just has a flood of DNS requests. The other thing that was sort of interesting is I don't think I ever realized how much noise we actually make, right? So in this case, and this is some of our test infrastructure as well, not just production stuff, but we've got 360,000 different DNS hits that we're coming back to our infrastructure. Like that's a lot of traffic. If you imagine from like red team perspective, maybe we should be tuning down how often we're calling back. Like 30 seconds seems like maybe an okay like time, but you realize, oh, that really adds up across all the hosts, all the beacons. Like that gets really noisy really fast. So just something to kind of be aware of too. And I think from like a defensive perspective, it's interesting because you're probably using some sort of, say you buy a domain, right, where you have no traffic to that domain, and all of a sudden you go from no traffic to like a whole bunch of traffic, right? There should be some sort of like shelving that happens if you're doing some like log tail analysis on that. I think it's just sort of interesting to start to visualize and think about like what are the implications of that. And a lot of this is way noisier than I thought it was going to be. And here's sort of the reason for adding all that MITRE TTP stuff into like the CNA script, excuse me, was that we can start to do some pretty sweet stuff like this. So this is a visualization that we built out in Elasticsearch that as we're doing engagement, literally is basically creating its own MITRE attack TTP map. So you can see here that some of the things that I probably wasn't thinking about, as far as like what are our most common tactics that we're using, show up here, like process hollowing. Like who knew that was like one of the most common ones that we do? It's like, well, okay, well, because of the way that Cobalt Strike, injects its new beacons and things like that's one of the top ones that we do. So it helps us in doing recommendations and prioritization of that type of work. Yeah, and so basically you can start now visualizing and understanding like what sort of things are going on within the infrastructure as it's going. You've got some pretty sweet stuff like this one was one of my favorite ones. You can see very clearly like patterns, right? So you can start to figure out like, oh, this is this employee. They're normally in from like 9 to 5 or whatever their times might be. And then you can sort of plan your operations around that. You can tell, like from this case where we've got some a little bit lower and slower beacons, and then we've also got our really fast working beacons too, so we can kind of keep an eye on that stuff. And everybody loves reporting, and now that everything is in some sort of like structured format, structured logging, you can do some pretty easy reporting with some of this stuff. So like this little Python script here will query Elasticsearch, pull out every time a new beacon was created with the beacon ID, the host name, and the user that was logged in at that time. So that way, now you got a nice little script to, you can dump it out to CSV and put that in some sort of timelining tool and get all that data out. So really sort of simplify your approach to things. So the gap so far is attacking from Windows systems. I haven't found a really awesome way of doing that. Cross-index correlation is kind of crappy. There's no like sub-select statements. And there's a lot of RAM involved in this because everything's Java-based. One request I have for tool makers is to add legit timestamps, ISO 8601, and same logging. So I want to add more Windows stuff, maybe feed some stuff in machine learning, do some more analysis on the data that we're actually getting back, and I'm out of time. So here's references and resources. I'll be posting the slides here shortly, and then eventually getting the code up there as well. I think I'm out of time, so I don't think I got any questions, but I'll be around if anybody wants to chat about it. Thank you.